For this video, I picked out a pretty difficult double angle formulae question. Most students struggle with this because with these types of questions, there's only one way of getting to the right answer, and you might take several steps that work in some questions but don't work in other questions. For example, when I first had a look at this, I was thinking to myself, okay, we're probably going to have to expand this out using what we know about double angle formulae, just like we've always been doing. So sine 2x is equal to 2 sine x cos x. If you'd like me to go through the double angle formulae, please let me know in the comments and I'll be sure to make a quick video about them. But this is strictly an A-star level question, so I'm going to assume you guys know what cos 2x and sin 2x can be written as. But just in case, I'll write out cos 2x too. So we can say it's cos squared x minus sin squared x. Or you can replace sin squared with 1 minus cos squared to make it 2 cos squared x minus 1. Or you can replace cos squared with 1 minus sin squared to make it 1 minus 2 sin squared x. Now the thing is, if you substitute those in, it actually complicates the question a lot more. What you can instead do is multiply both sides by 3 sine 2x, and that'll make it so that the left hand side will be left just with that numerator, 5 cos 2x plus sine 2x, whereas the right hand side will be 7 times 3 sine 2x, so that's 21 sine 2x. The reason why that helps is, well, there's two like terms, there's 2 sine 2x terms. We can take away sine 2x from both sides to get rid of the term on the left hand side. In that case, we'll be left with 5 cos 2x being equal to 20 sine 2x. Now, this is a lot easier to solve, but to make it even easier, you can divide both sides by 5, which then introduces you to cos 2x being equal to 4 sine 2x. Now, is it wise to use one of the formulae here? Well, actually, there's an even easier way to do it from here, and that is realizing that you can divide both sides by cos 2x. Why that helps is, well, cos 2x divided by itself will just equal 1. Sin 2x over cos 2x would be equal to tan 2x, because we know tan of any angle is sine of the angle divided by cos of the angle. That's how that trig identity works. It doesn't matter what the inside of the angle is, as long as it's being kept consistent throughout the question. You can then divide both sides by 4 and then solve for solutions of 2x. So let's do that here. Dividing both sides by 4, we get a quarter equals tan 2x. You can then do the inverse tan on both sides, so you get the inverse tan of a quarter is equal to 2x. And if you put that in a calculator, well, actually, one more thing. We're looking for solutions of 2x and not just solutions of x. So in order to find solutions of 2x, you want to double everything in our domain. So minus 90 will double to minus 180, x will double to 2x, and 90 will double to 180. Now that you've done that, if you put the inverse tan of a quarter in your calculator, you'll get a value of 14 degrees. What we know about tan values is that they repeat every 180 degrees. If you add 180 to 14, it goes outside of this range, so we don't include that in our answer. So, however, if you subtract 180, you get a solution that is still within this range. 14 take away 180 is actually minus 166 degrees. I know that it's not in chronological order, but these are your two solutions in this domain. However, we want solutions of x, and that's where we divide everything by 2. So minus 166, let's do that divided by 2 first, because that's negative, and that'll give you minus 83 degrees. 14 divided by 2 is 7, and that's your second and final answer for this question. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.